Hello and welcome to this building information modeling presentation. My name is George Milonas and I will be presenting a case study for a commercial boulevard. We are going to see, as you can see this slide in the outline, a brief description of the project, the general BIM requirements, the analytical BIM scope of work, how to model road and linearly dependent projects, the MEP utilities, and how we utilize automation to take out reports and quality checks on our models. And finally, we will see the laser scanning and implementations of it within such projects as roads and tunnels. The presentation is going to be divided in two parts, and this is the first part. In order to have a small description of the project, we have to say that this project is a 2.85 kilometers road and light rail train track with troughs, tunnels, and tunnel for the train as well, ancillary buildings such as stormwater tanks, pump stations, fire pump stations, electrical rooms, and a lot of MEP utilities such as district cooling elements, gas cooling elements, 66 kilovolt cable networks, potable water, fire water, storm, foul water and irrigation networks, and the road lining as well. So we have mechanical, electrical, water distribution, and all our steady elements like the roads, the tunnels for this project. This project had different scope per elements and different milestones per elements. We will not stay to this. The only thing that we need to stay and say is that we had an interface with other projects above and next to it, which means that at certain point we had to hand over the project to another contractor, take it back from them, and this times two. So it was a very, very difficult coordination process that required to be done in order to finish the interface between the contractors. You can see here two early stage images and two late stage images for the same location. You can see the dig over here and the base slabs being prepared. You can see now the reinforcement for the walls and the abutment walls starting, and the same location with the road layers finalized and in a more final stage just before the road demarcation. These projects are linear projects, as we'd like to call them, linearly dependent projects, which means that the construction of these types of projects has all their sub-elements depended by one or more linear alignments, which are called 3D alignments for the purposes of building information modeling and construction as well. Road layered structures, retaining walls, base slabs, roof slabs, abutment walls, tunnel tubes or bridge decks are examples of elements on such projects. The particular project, as we said, features a big road with a big tunnel, which has 3 tubes, and one is for each direction of the road, and additionally another one for the light rail train track. Moreover, a network of MEP utilities and that cover all the road length from either side of the road and occasionally above the tunnel, plus the interface with the connection of these utilities to the interfacing contractor. So it is usual in these infrastructure projects to have such elements, but this one is particularly difficult because in 3 dimensions we can see that it has a curvature along the horizontal plane and the dive down, because of the existence of the tunnel, to the vertical plane as well. So we have to combine 2 different curvatures in order to be able to model this particular project. The MP utilities had the special toolset that is going to be developed, that has been developed and utilized for this the modeling of these elements, which we will talk about in the second part of the presentation. This project had the unique characteristic that BIM was a contractual obligation. And as such, it required 3D design coordination for the design itself, in order to resolve all the design issues. It required 3D interface coordination of the utilities within the package and with the other packages, as we said, the projects that we were interfacing with. We had to include the construction and site management, monitor the progress of the project, control it, the cost of it as well. We had to prepare and link the closeout documentation and handover package for information and data management for the geographical information system and other local authorities to prepare the operation and maintenance of this project when it is going to be functioning. And finally, the contractor of this project utilized this model to provide federated and fully coordinated building information models representing always the latest available information of the project. Continuing to this, we can see over here that some of the early deliverables as per the contractual obligations was the BIM execution plan and the modeling guidelines, which are the driving forces between modeling and design or drawings in order to implement this in our building information modeling processes. So apart from the documents that defined the processes, we had to do some test cases to see that they are working. These test cases was for the initial modeling and reporting of such elements as a drawings register and the baseline model, which will be freezed and considered the first revision, the zero revision in better terms, for the issued for construction drawings. This was the early deliverables phase. In the implementation phase, we had to deliver model sets, full sets of the models, plus Navisworks and WC extractions from the model. We had to deliver a 4D and 5D database, which means the model had to be linked with the schedules of the construction activities and with the BOQ elements, the cost of them and the quantity of them. Additionally, for the implementation phase, we had to do a class detection analysis on the design models to identify all the design problems that we had from the initial design per a breakdown that we had on our WBS. And the same thing should be repeated for the shop drawing models, because the shop drawing models may contain clashes which need to be resolved before we reach on the construction phase. Over here, you can see the class detection analysis results, some samples within our scope, which are created from Bentley Navigator, which is a program that automatically and dynamically assigns clash numbers on layouts that we are designing in our BIM center, assigning responsibilities, the time that we found it, the status of it, meaning that we keep track of it, and any different change that we have from stage to stage, from IFC to construction to as-built. Beyond this analysis, as we said, in the implementation phase, we had to deliver monthly deliverables to our client, monthly BIM deliverables. Here you can see them broken down as per folders and subfolders, but the overall image that we need to keep in mind is that we had to deliver our work in progress models in the IFC format and in all the formats that we had to utilize based on the contractual requirements, our shop drawing models and class detection analysis of them, and the data that comes with the model, which is the 4D and 5D database. This was the backbone of the monthly deliverables. Additionally to that, we had to utilize another phase, because it's not just the early phase, the implementation phase, it's the closeout phase. In the closeout phase, we have the final 3D as-built models, the drawing register and model register, the as-built database, which will consist of all the quantification data of the as-built model, and the documentation of the executed quality checks in order to verify that those models are correct as per the as-built drawings, and of course, the laser point scan point clouds, as you can see here. So there is a scan from the tunnel at the construction period. You can see a section of the tunnel, and here we can see a top view of the tunnel with elements that have been erased manually and with automated processes that will not affect our construction. Aside these elements that we had to do for our client, there was the internal as well scope of work that we have been utilizing BIM for. We have to understand that beyond a client, we have a team that needs to understand a very complex project. And for this, we are utilizing visualizations and animations, such as this visualization, that will give them a very good idea of what is expected to be built in different phases. This, for example, is a general overall view, which is around 3 meters in this dimension, and another 1.5 meters over here that was in our project's entrance. Additionally, we had to track and report the progress of certain elements. As you can see here, there is a progress report for concrete elements at a given, let's say, time on our project. And here you can see the progress of backfilling. Red elements, the elements that have not been built and needed to be built, and green elements, the ones that have been built at the given time of the reports. In this point, we will stop the first part of our presentation. Thank you very much.